So who's here and has been to the moon before? Nobody? Oh, we got Neil Armstrong in the audience over here. Let's play a little game. I'm going to need everyone to stand up. Now, I need you to imagine that we are 60 or 70 years back in time before anyone has been to the moon. Can you do that? To make it a bit more real, I'll put the slide in black and white. So, who here wants to go to the moon, given that no one has ever been to the moon before? We've seen it all in the sky. Okay, if you're putting your hand up, you can sit down. That was pretty easy. I didn't even tell you that you'd be flying in this thing. Now, I've got something that might help for the people still standing. Let me get this out. We've got a rocket ship here. Now, what if you could fly in one like this, but obviously bigger? Now, it's pretty shiny, has nice windows, there's comfy seats and all that good stuff. Now, would you want to go to the moon? Yeah, if you do, you can sit down. To the people still standing, what if I tell you you don't need to do the 12 months of astronaut training? Oops, I forgot to tell you people sitting down about that. But what if you don't have to do the 12 months of astronaut training and you can just be a passenger instead? Now, do you want to go to the moon? If so, you can sit down. Okay, what about if instead of it taking multiple days to get to the moon, it'll now just take a few minutes instead? Would you go now? You can sit down if you would. Okay, still a few people standing. What if I tell you it's free? But wait, there's more. You can even fly in zero gravity on the way there. Now, do you want to go to the moon? You can sit down if you do. Okay, to those of you still standing, thank you for being skeptical. I'm pleased to tell you that congratulations, you have now all successfully been able to apply for jobs in risk management. You can sit down. So what's really interesting is that data mesh is quite similar to going to the moon. Some people are really keen and they'll come without any prompting. Others need a bit more encouragement. They need some perks or some extra time. Some people just want to know it's free, right? But for the early adopters, we also have some unexpected surprises or things that make it harder than we initially expected. Then we have the skeptics, the people that want to see someone else do it before they commit. So today, we're going to talk about our journey at ANZ, the strategies and tools that we used and how you can use those to embark on a similar journey yourselves. So why are we even doing data mesh? People come up to me all the time and they say, hey, Adric, why are you even doing this data mesh thing when I've got all my data in Excel already? So I've been fortunate enough to work at a number of large companies with large number of employees and large number of data sources. And sometimes challenges come from working at this scale. There's essentially 4 key themes that tend to come out. The first one is about how we work together. It's really hard to deliver an outcome when teams are working in silos. When a change spans across multiple teams, objectives aren't aligned or the handovers cause friction. This tends to result in complex transform and load processes where business logic gets hidden, or even worse, duplicated. Then your data lake, which is intended to be this asset for your organization, turns into a bit of a swamp, a dumping ground, if you will, one that even Marie Kondo couldn't help you declutter. So we're all in this industry as practitioners of data because we love what we do. But sometimes it's not always fairy tales. Sometimes it feels like a horror movie, right? With corrupted files, missing data, midnight phone calls. If you need to use a legacy system running software from the year 2000, if you need to chase approvals, go into meetings, or perform an update across multiple locations or repositories. The worst one I've seen is a simple name change. Took someone 140 clicks manually. The third theme is around expertise. If you're at a small company, you might have, let's say, 3 data sources. You might have a website to take your sales. You might have a CRM to manage your customer relationship. You might have an ERP to do your business admin. That's cool, that's manageable. But if you're in a large organization, for example, one the size of ANZ, it's really, really hard for people in the data or warehouse team to be across the hundreds of data sources there are. The cognitive load is just too great. So what happens? Well, the backlog for this data team, it grows and grows and grows, going from days to weeks to months. So here, if I said to you, I'd do something for you in 12 months' time, how would you feel? I didn't want to hear what he said, but he did not look happy. The last theme is around how we practice the craft of data. If someone's building a rocket ship like this one, there's certain expectations you would have. I know for me, I would expect all the parts to be available with nothing missing. I'd expect it to be of high quality, nothing damaged or broken. I'd expect it to do what it's supposed to do, fly up and then land safely. And lastly, I'd expect it to be ready on time, before the due date. So what's really interesting is when we take these product practices for our rocket ship as an analogy to data, what's unacceptable for the rocket ship too often is acceptable in the data world. So I'm sure that some of these challenges are quite consistent with what many of you have experienced in this room. I'd like to widen our apertures a little bit and think about the world of applications. Applications once upon a time were monolithic too. How did they change? Well, we started with microservices. This gave a shift for applications to be able to be more frequent and more reliable. And until recently, we didn't have a similar inflection point for data. So that's where the data mesh philosophy comes in. The data mesh philosophy is about treating data as a product, and this product is quite similar to the microservices, but for data. Now, I'm sure all of you have sat before and listened to Data Mesh 101 talks or videos or read articles. You heard about the 4 key principles, blah, blah, blah. I'm not here to bore you with that. But I would really like to understand what it is we're doing and why. So let's quickly recap around our domain-owned products that have ownership and accountability, decentralization rather than centralization, and the magic source of the self-service. So what does this actually mean? How do we make it tangible? we need to focus on actual users of our data mesh and think of what these means for them. So for our users, our data product consumers, they need to be able to find, discover the data, and ensure they can trust it, most importantly. For the owners, we want to help them create and share their data products. We also want to make sure there's the right standards and governance to ensure there's no exposures or breaches. And we want the reusable patterns and capabilities. We want those able to be built so that everyone doesn't have to wait for a central team to do things. Now, I mentioned decentralization. And so in terms of how we work, we've taken inspiration from the Goldilocks principle. Now, if you don't remember who Goldilocks was, I'll let you go home and read your favorite book of fairy tales. But in terms of operating models, you have three main choices, right? You have the centralized approach, which is great at providing consistency and standardization. But as we heard before, it lacks the ability to scale and can create silos. You might say that sounds too hot. Then at the other end of the scale, you have decentralization. So this is great about promoting autonomy and agility, but can risk duplication or silos. Sounds too cold. And then in the middle, you have federation. This is like a hybrid of the first two. It allows you to really turbocharge what you're doing with both standardization and autonomy, although with the caveat that you really need to ensure interoperability through standards and interfaces so people can work together. Sounds just right. The emphasis here is that there's no one-size-fits-all approach. Whatever is best in the context of your organization is the way to go. So, to our organization, ANZ, we call our data ecosystem the cosmos. Cosmos doesn't just mean a universe, it also means a well-ordered whole. Pythagoras actually coined the term to mean something beautiful to look at. I don't know about you, but if you've seen some of those spreadsheet jungles out there lately, they're definitely not beautiful to look at. So our journey to the cosmos starts in phase 1 of 3. And that first phase we'll talk about today, which is getting to the moon, our first step pioneering into outer space or data mesh. Then our second phase will be about how we grow and deepen that work, getting to the edge of the Milky Way. And our third and final phase is about scaling, exploring, uniting other galaxies, a mesh of meshes approach. So microservices are great if you're an engineer, but how do you explain data mesh to your parents? How do you tell them what you work on day to day? Well, we like to think of data mesh as YouTube for data. Why does this work? Well, if you think about YouTube, you create videos, you create content. It needs to meet certain standards, certain formats, and then you upload it. And people wanting to watch or consume those videos can go to YouTube, find what they want, and watch it. This is quite similar to data mesh. We're doing similar things with our data products to create them and then consume them. So if we're here in the first phase of our journey to the cosmos, creating our data mesh, we need to start somewhere. Where can we start? If we're building this exchange or marketplace, it makes sense that we need to get both supply and demand, right? That's how an exchange works. Although typically, without a supply, there's not going to be any demand. So we need to focus on the supply. So for us, we thought, who can we take inspiration from? Who in the recent history has built a really successful exchange or marketplace that we can take inspiration from? So who here's used Airbnb? Yep, most of us. Airbnb actually started in New York. And once it started to gain traction, it expanded across more states, across North America, and eventually into most of the major cities we see in the world today. How did they do it? Well, they constrained the market geographically before they built it. A similar example, Amazon. They started just selling books. Then they got really good at it. And they started selling more products and more products until now you can buy practically anything from Amazon. So they constrained the market categorically before they expanded and grew. So for us, we're not building Amazon, we're not building Airbnb, we're just building a data mesh. What could we constrain with? To answer that, we need to think, what is it that we're actually building? What is it in data mesh? What makes it up? So we listed out 15 capabilities that we needed to build. We split those 15 capabilities into 3 core areas. Compose is about making the process to create a data product as simple and frictionless as possible. Manage is about helping people control the mesh through interfaces, services, and libraries. And then trust is about having faith in the data, enabling people to find, discover, and share their data. This is interesting, but we really needed to scope down what we were going to do to create what we called our MVM, our minimum viable mesh. So we picked the 4 boxes on the screen as just the 4 capabilities that will give us enough that we could go out and bring people who wanted to help share and publish their data on the journey with us. A spoiler alert, by implementing just the first iteration of these 4 capabilities, the first iteration, we were able to reduce what previously took 5 months to 2 weeks. 5 months to 2 weeks. And that's a repeatable process. Not only that, but this is the first iteration of these capabilities. So as we start to build and improve on them, they're going to snowball and improve even more. So I'm not sure if any of you heard, but NASA was actually experimenting with rockets without engines. Did any of you hear about that? Rockets without engines? It didn't take off. But we wanted to grow the foundations of what we were building into something great. We wanted to take off and reach the moon. So we implemented a few of what we call mesh predictors. These will help you accelerate what you're doing and mesh predict your work, if you will. Now, we needed these accelerators because at ANZ, we've been working really hard to build data products to power our new ANZ Plus application with features like expense prediction. ANZ Plus is a reimagining of how we bank that provides tools and support to help people with their financial well-being. It's wrapped into one system that helps you trust and make the most of your money. So as we start to build these data products for the ANZ Plus application, it's vital we understand what it is we're building and who we're building for. This is where data contracts come into play. Now, we refer to this generally as data product specifications, and we started with a really simplistic YAML file. That's where we all start, right? And we put in a few things and it started to grow and grow over time. Now, we quickly realized this wasn't going to scale. What we're doing was veering our own course, and it was getting quite complex. We were trying to describe the intent of the data product, the metadata. We were trying to establish quality standards. We were also trying to ensure trust and understanding. We realized we were a bit out of our depth. So that's when we decided to have a look at what is out there. Now, I could do an entire talk on how we chose and the reasons why we chose this particular standard, but I'll just mention briefly today we chose the Open Data Mesh, which you can find at opendatamesh.org. And this is awesome. You don't often get people here raving about standards. But you can see here on the left, we have a JSON example, and on the right, a YAML. I don't want to buy into any JSON YAML tab for spaces debates. And it really succinctly captures metadata about the product, the owners, the inputs, the outputs. What we most liked, though, was its extensibility, because you can't cover everything in a standard. You can't be all things to all people. But you can provide an extension point where people can adjust it as they need for things like observability, for freshness of data, which are important things for us in our early stages. It's also composable. No one wants to write a 1,000-line YAML file, so you can actually split it up into multiple files. And of course, as the name suggests, it's open source. Everyone wins. So as we started to do this, it unlocked a piece of the puzzle, but interrelated to that is the data products and the types. So for those of you that have read Jamak's book about data mesh, she mentions 3 kinds of data products: source aligned, aggregated, and consumer aligned. Now for us, we still have source aligned data products, but we needed a bit more complexity to that. So we created subtypes, let's call them, self-owned and proxy. Why do we do this? So as our early stages of data mesh, not everyone is ready to create data products, whether it's a skills or a time, resources. We need to be able to cater for everyone. So we actually had teams working on premise that weren't ready to use the cloud, but we had data needing to be analyzed and used. So this concept of proxy meant that someone could create a data product and run it on behalf as a proxy for the source system owner. And this gave us 2 main benefits. Not only the transparency for the source system owner to see what was happening to their data, but also the ability to then transition the data product to that source system owner when the time was right. There's also a common problem with aggregated and consumer-aligned data products. So for many people, the distinction wasn't quite clear, nor was a distinction even necessary in many use cases. So what we did was we actually wrapped these 2 together and called them integrated. So for different people, aggregated means different things. Yeah, integrated is quite clear. It's about combining 2 different sources or 2 or more. So as we did this, we also realized that we needed to create tiers of products as well. We had some things where people were just doing to create a data set to publish to their dashboard, right? They were making it very wide or very narrow. Didn't really need to share it. Didn't really need high availability. And we called this a single purpose tier. But then on the other hand, you have your tier 1 data products where you might be publishing numbers that go to the execs. You need that stuff to be bang on, right? You don't want the exec coming to your door asking why the number's wrong or why it's not available. As we started talking about mesh, people started to make up their own words. For example, node. People used node to refer to a data product. So what we actually did was we decided to use this term node as a collection of data products, meaning that when we started providing services like infrastructure or sidecars, we could do it to a data product owner that owned a collection of data products rather than individually repeating the same things. And lastly, given how hard language was, expecting everyone to do things immediately was, I guess, like our game to the moon earlier. We had experts in data, engineers, modelers, analysts, and we got them to pair with the application teams to help deliver the first iteration of these data products. This meant we could drive business value. So speaking of business value, let's change gears. What do we have planned next in our journey to the cosmos? There's a heap of things I'm really excited to do. Heaps. The shift from legacy to mesh is big because we're driving a culture change. We're going from, hey, the data team will do it, to putting the onus on the application teams. We also want to empower our analysts to be able to create their own data products and insights. And it's not just an awareness and adoption challenge. There's also operating model. Who owns this stuff that we're building? Who maintains and supports it going forward? What are the rules around the frequency of those? We also want to provide more capabilities for output, things like APIs and files. I'm a huge fan of GraphQL, as well as self-service, so people can run their own race through a user interface or easy tooling. But if I could go back in time, what advice would I give my past self? Aside from the winning lotto numbers, of course, there's 3 key lessons. The first lesson is to start small. We picked a problem of data mesh and we scoped it down to those 4 capabilities. So it was an important problem across the vast space. But the lesson was actually start even smaller. Because what happened was, in our excitement, we actually created 2 reusable capabilities. One for file and one for data stores. Instead of creating just one awesome capability, we split our energy and our focus on 2. So this brings me to the next point, know your customer. Well, why did we get it wrong? So it turns out all these application teams we were trying to help, we thought they just wanted to replicate or sync their data from their application data store straight into their data product. But it turns out they'd already built an abstraction layer. So all they really wanted was an event stream to go straight into their data product. And that was a capability we could have built that would have saved a lot of time and decoupled everything. Another thing to think about is your customers' deadlines. Because if you're out helping a customer to deliver something and they have a tight deadline, that deadline becomes your deadline. And unless you're all across the page on this, it can create friction and you can lose the appetite for adoption in the short term. The third lesson was around, or inspired by, the network effect. The network effect says that if you have a product or service, the more valuable it is, the more users you have. The more users you have, the more valuable it is, right? So it's co-create. We started with a staged approach, going with our internal consumers and then our external. But it turns out a lot of the problems we discovered with our external consumers. And so this is a good lesson for us. We also want to turn our promoters into advocates. You want your first customer to become an advocate for your second and third customers. Even in a large organization, people want to know someone, somewhere, has put your thing into production before. So there you have it. That's the journey for ANZ and data mesh so far. And I want to leave you with one final thought. It's one small step for mesh, one giant leap for ANZ. Thank you.